Okay, so for this video I'll be discussing floating point multiplication for ECEN 350. My name is Bijan Sadikian, and I'm doing this for a class. So we previously have discussed how floating point numbers are written. For this example, I won't be going over that, but for this example I'll be using the numbers 0.5 and negative 0.4375. There is a video to explain how these numbers are created, but these are the IEEE 742 format representations of these numbers. You can see that 0.5 is positive arrow. There are 23 bits for the fraction, and then 8 bits for the exponent. And then for negative 0.4375, it is actually a negative sign bit, a 1. And I don't know why this paint is not working. Irritating. Okay. So, you can see here that well, this is the IEEE representation. Okay, written in, I guess, scientific notation for binary numbers, negative 0.4375 is also written as negative 1.11 times 2 to the negative 2, and 0.5 is written as 1.0 times 2 to the negative 1. These are the numbers that we will be using for multiplication. Let me get a new page real quick. Okay, I'm just going to write these numbers at the top because we'll be using those. Okay, for multiplying floating point numbers, there are 4 steps. The first step is essentially to take the normalized, when they're normalized they have an exponent. Take those exponents and add them together. Negative 1 and negative 2 add together to be negative 3. This gives us the exponent of what will be our final product. 2 to the negative 3 is what we'll be multiplying our final product by. Step 2 is we need to take the two, I forgot what they're called, the two pieces in front of the exponent, and we will be multiplying them together. This is the format that we'll be using. The top one is known as the multiplicand, and the bottom one is the multiplier. We will be using the multiplicand, and essentially we'll be taking, it'll work exactly like a decimal or multiplication would. We will take the least significant bit of the multiplicand, which is on the far right, and we will multiply it through with all of the multiplier. 0 and 1 is 0, 1 and 1 is 1. So this multiplies through to be 0, 0, 0, 0. The next step is we take the second least significant bit and do the same thing, except this time our products, what we multiply together, will actually be shifted and started right here. It's exactly like decimal multiplication. And we will follow through and do the same thing for each of the 4 bits of the multiplicand, which will give us these numbers. The next step we need to do is sum all of these together. There's a floating point adder video that someone else did, which is excellent, and if you need to know how to do this, you can go to their video. But this is how ours comes across. And then we take the decimal, we put a decimal right after the most significant bit and multiply by the exponent that we got in step 1. As you can see, this is our final, well, this is not our final, but this is our multiplied product. The step 3 is actually to take this product we received and take it down to only the significant figures that we previously have been using. So we would end up with 1.110 times 2 to the negative 3. And for step 4, since one of our numbers is negative and one of them is positive, we will obviously end up with a negative number with, you know, simple math. Ways to know if it's negative or positive obviously is from the decimal, or if you were originally working from IEEE format, one would have a signed bit, one would have a no signed bit, or 0, 1. And so since they are, one's positive and one's negative, we put the negative in front of it, and this gives us our final answer. A way to check is to convert it back to decimal, and we see we get 0.21875. You can compare this with multiplying 0.5 and negative 0.4375, which will give you the same results. Thank you for your time.